name is Lily. My pronouns are she, her, and I'm a software engineer and a serial crafter. Ooh. Focus on slide. Click on slide. In my spare time, and sometimes even at work during my lunch breaks, I crochet. So I guess that also means I work in software engineering. If you like terrible puns, don't worry, they'll keep coming. When I first learned to crochet, this picture tells me it was back in 2014, I was getting hooked on making little flower after little flower. I realized, being a developer, that I was basically doing a computer's job, parsing instructions at runtime and following an algorithm. And this made me think that crochet and other yarn crafts more broadly were maybe a form of programming hidden in plain sight. And by the way, thanks for the spoiler, Remy. For those of you expecting a talk about package managers, sorry. Today we're talking about the fluffy kind. Is it working? Yes. This is simultaneously very satisfying and horrifying. I'm very glad someone did it, not me. So I'm going to be talking mainly about crochet because this is the craft I know best, but it could also apply to other crafts like knitting, needlepoint, cross-stitch, all of them, as they all rest on the same underlying principle. And it seems crochet is quite popular these days if we look at Google Trends. So the blue line is knitting searches since 2004, and crochet is in red. And I'm slightly disappointed that there wasn't a bigger spike in the last couple of years as everyone tried to reproduce the Harry Styles cardigan. The first similarity we can see between developer and crocheter is the community. That's brought to you by the power of the internet. If I want to learn about a programming framework, I look for a blog, a screencast, a video, a forum. If I want to learn new crochet techniques, I can do the same. I actually learned to crochet by pausing, rewinding, and trying to copy YouTube videos. Before crochet terms became more common in the middle of the 20th century, the books of patterns you could find were of actual samples that you could study and reproduce, a bit like me trying to reproduce the YouTube video, but more tactile. And to me, that feels surprisingly like a CodePen or Gist or Stack Overflow, all those online platforms where you can share snippets of your code to be reviewed and reused. And if we look at the history of crochet and computing in parallel, we can find more similarities, not only in the way of programming, but also in the behavior of their respective communities. Tech, after all, is more about people than computers. So let's look at the tangled history of crochet and computing. Similarities occur at the very root of computing and yarn crafts. There is often a discussion on whether software development is a science or, in fact, a craft. Both science and craft imply a competency, a skill from an operator. But in people's minds, tech equals science because we need to solve a lot of equations to get to where we are today. Science instantly evokes knowledge, empirical data, whereas the word craft, coming from the Old English creft, evolved to mean something built or made. Well, I don't know about the programmers among you, but I often spend my days trying to waiting for my builds to finish. And in software, we also thrive to refactor our code to find more elegant, more crafty solutions. And in crafting, there is the notion of transmission, maybe to an apprentice or a community, that we also find in software, conferences like today being a prime example of that. So it looks to me like we're indeed going to be comparing two crafts. This is Mademoiselle Eleanor Riego de la Branchardière, or Mademoiselle Riego for short. And contrary to what a name might suggest, she lived in Ireland. We don't know much about this lady's background and origins, but she was a very influential figure in the 19th century world of yarn crafts, particularly lace and Irish crochet. She wrote dozens of pattern books, allegedly from a very young age. I think I read somewhere 10 or 12 years old. And a little interesting fact about Irish lace. In Ireland, it's said that you live a bit of your soul trapped in everything you crochet. So to avoid this, you should always work a hidden mistake so that your soul can escape. This is similar to other superstitions in woven textiles. For example, rugs made in the Middle East have deliberate flaws so as not to offend God with their perfection. And to me, that sounds very much like the all too familiar, this is a feature, not a bug, excuse that we all have in programming. Back to Mademoiselle Riego and her pattern books. In my opinion, she was a pioneer in open source crochet, of course. But let me explain my reasoning. As I said, she was very prolific in publishing pattern books. But those pattern books were of actual samples because there were no defined terms for the stitches at the time, so you couldn't write them down. And so instead, people would easily reproduce and amend those patterns, a bit like reverse engineering them by exploring the source code. This evolved in the 20th century when yarn manufacturers themselves paid designers to crochet samples of their design directly on the end of yarn so that they'd be sold and you could take the pattern home with you and carry it straight away. Just like forking a project, making your own adjustments and little tweaks to the source. Speaking of which, the modern GitHub/version control platform with input and feedback from the community for crochet is Ravelry. There are also other platforms, and I should point out that they've had slightly bad press lately for their non-accessible website redesign. But on these platforms, designers post their patterns for other crafters to use, make, or test. And posting feedback or recommendations is akin to opening an issue or a pull request, as you do for code. Crochet and computer software have both evolved over time through innovation, natural selection, and their respective communities. And the evolution goes a bit like this. You borrow some code, modify it, test it, fix it, modify it, test it, fix it. And after a few iterations, you share it, preferably when it's fixed or at least tested. This is Jacques de Vaucanson, a Frenchman and fairly clever cookie. His specialty was building automatons in the first half of the 18th century. For the little backstory, it goes that he built a mechanical duck and fooled everyone into thinking that the duck had an actual digestive system and could produce organic matter. Totally unrelated, he then became a director of silk mills in France, and that's really where the interweaving starts. In 1745, he toyed with the idea of a punch card system for controlling weaving patterns, trying to automate a very manual process. This helped the foundation of the jacquard loom in 1801, which in turn influenced the early history of computing, as you might know. Here's how weaving looms work. This one doesn't have punch card, but is made of Lego, so that makes up for it, right? This sound isn't very important. There is sound on it later. Dozens of these on YouTube. It's a very time sink if you're into looms and Lego. That's the place to be. The first IBM computers were also reliant on punch cards, and before that, women would be hired as human computers performing complex calculations by hand. But let's not jump the gun, and let's rewind to Ada Lovelace, who in the middle of the 19th century, in around 1842, so about 100 years after Vaucanson's punch card idea, helped Charles Babbage in his endeavor to build the analytical engine, heavily inspired by the jacquard loom and punch card system. In her own words, the analytical engine weaves algebraic patterns, just as the jacquard loom weaves flowers and leaves. The terminology of different parts of the engine is also borrowed from the textile industry. In textile, the yarns are brought to the store from the mill, where they're woven into fabrics and then sent back to the store. In the analytical engine, it isn't yarn, but numbers that are brought to the store from the arithmetic mill for processing, and the results of the computations are returned to the store. And the analytical engine was purely dedicated to calculus, whereas Ada Lovelace saw beyond simple arithmetic and envisaged more complex tasks being performed. This is why she's deemed the first computer programmer, creating algorithms and patterns to be computed by this new machine, even if it was never finished. Just like Mademoiselle Riego created crochet patterns to be computed by humans. But in a way, a crocheter always counting stitches is like an organic analytical engine, with the stitch as the instruction and the yarn being fed through the hook like data into a compiler. By now, I hope you can see more parallels emerging between crochet and computing. And if we follow the thread a little further, we could say that computer software and crochet software appeared around the same time if we define software as being the programs and information used by a computer. We've already established that there are human computers, so there is such thing as crochet software. There's even knitting software for retro computers. Stretching the theory on crochet software a little more, we could affirm that it is a form of self-replicating information that gets passed on from one crocheter to the next. The early recorded techniques for crochet were so simple to learn that they became automatic to perform. People would start crocheting while talking, praying, traveling, eating, as I do on my lunch breaks, or watching TV. So there is a form of automation in both mechanical and human computers. In Ireland, crochet techniques evolved and spread at a time when adults and children alike had to adapt their skills to find new streams of revenue. And revenue, some of them could get through crochet and selling the finished items. Similarly, today we see a multiplication of code clubs, women who code initiatives, spreading coding techniques far and wide. Let's talk about the stitches now. In the mid-19th century, there was a reduced number of stitches compared to today. Their name didn't matter as no instructions were written down yet. Apart from the chain up there, I don't think those names are still in use today. But we'll see an evolution of the programming language emerge a bit later on. Let's get technical. No matter how complex the crochet stitch, it always starts with one loop on the hook and ends with one. There's probably a good metaphor for the event loop for programmers there. But I won't dig into that detail today. There is a pre-production process in crocheting where you select your yarn type, your hook size, check the tension as per instructions. And in a way, it's like making a small unit test. You end up assembling a few rows together and measuring the output to ensure it is as expected before you go too far. By 1950, the names of the basic stitches printed in the UK have finally been standardized. Hooray! Universal programming language. I think not. At the time, and even today, a high proportion of other English-speaking countries still use different names. So if you're unaware of the differences, your end result will be far from the expected one. Fundamentally, different stitches can share the same name in distinct languages. So let's play spot the difference. A UK double crochet is a US single crochet, which means they correspond to the same yarn hook gesture. Now, a US double crochet is a UK treble crochet, and so on as we go down the list. And that's just for English-speaking countries, but other languages have their own terms and translations. So American English doesn't rule the world of crochet programming languages, but it is widely spread. Luckily, and you might have spotted the translation on the previous slide, there is also a visual language, a source language, if you will. That's your binary zeros and ones that can be translated into your own local version. No matter what language you speak, each symbol on this chart will correspond to the same stitch for you to crochet. Now, if we look at written patterns, that's what part of a written pattern would like. This one is from Yarnspirations, which is another good resources for patterns. And if we read through, we can see scalability in the various sizes. You can make medium, small, or large there. Variables in the color changes. They're even assigned to A, B, and C variable names. Probably could do better on naming. And loops and recursions with all the repeats. Stitches can be combined into a near infinite number of designs, just like the primitive elements of a programming language can be combined into any program. These crochet instructions were written in, say, JavaScript, for example. Well, they might look a bit like that. Both in crochet and programming, it doesn't matter what language you know, as long as you understand the underlying logic. Now it's time for the live demo. I have yarn. These kinds of live demo don't fail as often as coding ones do, so I'm hopeful. So, where am I? I'm here. Here I am. A human computer with a compiler in my hand, interpreting a pattern at runtime. I have prepared for today, but it's fair to say it hasn't been loaded into memory, so I'm reading the instructions off my screen. Although someone pointed out the other day, and I think they have a point, that freehanding a pattern once you know a bit about the craft is like a machine learning algorithm trying new things and stitching together new images. So here's a DALL-E image images I generated earlier. I have some more at the end of the talk if we have some time to look at them. So, yes, as I come to change of color in the pattern, I will have to deal with literal multi-threading. I need to manage two different strands of yarn at the same time, and it's tricky. And while I crochet, I can sometimes encounter race conditions, either if I run out of yarn before I'm done using it, that's also known as thread chicken, or if my mind jumps ahead and I miscount. Crochet and programming even share the same language at times. Take blocking, for example. Thread blocking in software means your thread is suspended, and more often than not, your application will hang or crash. In Yarncrafts, it means fixing panels of a garment to the correct shape and size, effectively preventing them from moving and getting misshapen. The only acceptable form of blockchain is with yarn. Now, if I make a mistake, what tools do I have for debugging? Well, the problem with a crochet pattern is that you can't really see the result until it's been fully compiled. But you can put breakpoints and step through your code, meaning you can wait until the next row, the next round, to see if things align properly. And because it's just a big interwoven loop, crochet items are easy to unravel, slightly harder with knitting, without creating a waste of thread, just waste of time. Once you've finished compiling, of course, there's the mandatory post-production step of weaving the ends in. The design is still in beta and won't be deemed production ready if you haven't done this step. It's a bit as if you've left lorem ipsum in your content and hit publish. That's a no-go. You can choose to document your code with a README or wiki, that'd be the pattern, or add comments if you've improved on an existing design, because how often do we really write code from scratch? Hacking with yarn. Now that we've got the basic mechanics of crochet down, let's make things interesting and look at how we can mix this analog medium with digital. There are many ways people have been hacking crochet through the years, diverting it from its primary purpose. Yarn crafters have been experimenting with cryptography, hiding secret codes and messages in their items from very early on, sometimes to denote belonging to a community or a particular social rank. Phyllis Latour, for example, was a British secret agent who used her knitting needles to hide coded messages she sent from Normandy during World War II, and she turned 101 last year. In recent years, Eden Cottage Yarns also paid tribute to the human computers of Bletchley Park with a collection of knitting and crochet designs such as this cardigan with a Morse code message on the back. Another way to spruce up crochet is to ditch regular yarn and replace it with electroluminescent wire. Anyone for the after party? There are many other ways to bring together yarn and technology or engineering together. Sometimes you can give control back to the machines, either with a 3D printer, this one, or even mechanically with a knitting machine or knitting chair. Person on the chair looked quite uncomfortable there. Don't know what you'd do if you dropped a stitch. A few years ago, Google and their Project Jacquard, and that name should be familiar by now, transform woven fabric into a touch interface. But it's not much fun if you leave the computers do all the work. Yarn crafting is, after all, a hobby. So in a more DIY fashion, we could see the same kind of interface with conductive thread being knitted or crocheted into garments. And for even more fun, there are also games made from knitting machines, leaving the output to players. This is Hazuki Knit, where the speed of the knitting, controlled by player 1, down here, determines the speed at which the game prompts appear on the screen for player 2, and they have to respond with arcade-style buttons. This looks extremely fun. I've never got a chance to play it, but I wish I could. If you prefer more structured patterns, technology can also enhance your approach to crochet. There is a technique in crochet called C2C, corner to corner, where, based on a grid design, you combine stitches into little pixels of yarn to reproduce the pattern. The difference with using regular grids and corner to corner is that instead of working in rows and columns, as you would in cross-stitch, for example, you work in diagonals and in alternate direction at the end of each. So I don't know if you can see the arrows really well, but it goes this way, then 2 this way, then 3 that way, etc. as it grows and you reach the top left corner. When I made my first pixel blanket, the most tedious part was to stop and count tiny squares on a sheet of paper and cross out the ones I had done. It slowed me down massively, so I fixed it. I opened my favorite code editor and built myself a framework to create patterns. It's ugly, but it works. And as well as making patterns and estimating the amount of yarn I need, this app reads them out to me diagonally, alternately, and by group of color. And now that was a drastic performance optimization for me. Having a voice reading out patterns could also unlock access to crochet for a wider range of people. Just like software, crochet is also concerned with accessibility issues. This person, for example, had to learn a different way of crocheting after suffering a stroke. Let's listen to their story.
So you have a contraption that's been made for you?
Yes. It was actually made for me by Mississauga Hospital. And when I had the stroke and went to a rehab, and that's when they did it. And actually, they did it with knitting needles in it. And at the time, I could do plastic canvas that way. But I went home and I thought, okay, how can I do this with crochet? So I did. I finagled 2 elastic bands to put it in so it holds it steady. And I've done everything with it.
Wow, good for you. That's neat.
Yep.
Where there's a will, there's a way, right?
Exactly.
A lot of stroke sufferers learn one-headed crochet, and this is a solution that's probably inspired by the way of crocheting in the early 19th century. In the 1820s, one would hold both yarn and hook in the right hand, and I don't know if I can demo here, and pass the yarn over the hook with their forefinger. I have never tried this. I don't know why I decided to try it. This is the fail demo, everyone. And this changed in the 1840s to the technique we know today with the yarn and hook in different hands. Accessibility in yarn crafts has been a concern for a long time. Remember Mademoiselle Riego? Well, she received a certificate of merit in 1871 for teaching to crochet a blind lady who then went on to make items for the Pope. As we've seen, yarn crafts may encounter the same issues faced by software developers and tries to tackle them through innovation. I've explored with you the similarities and parallels of crochet and programming, and I hope you'll agree that crochet is a programming language, which means that if you're a programmer, you can become a yarn crafter, and vice versa. To conclude, I'll say this. Teaching new generations to code won't make them all software engineers, but it will give them the basis for logical thinking and problem solving that can be applied almost everywhere. So if you don't have access to enough computers, or are worried about screen time, or want to appeal to girls because computers are for boys, they're not for boys, they're for everyone of any age and any gender. So is crochet. Thank you. Resources and images. I'll take the applause afterwards. Resources and images are at this link. I know there's no time for questions, but always happy to chat about yarn or new ways of programming, so find me in the break. Thank you.